All right, well, it's kind of trickling now, so I might as well get started. So my name is Aaron Falk, and this is the Request for Conversation event, Hotrfc. This is, I think, the fourth time that we've done this event, and people seem enthusiastic about it, so I'll be interested in getting feedback at the end of the night if you think this is good. The point of this event is to have a series of lightning talks that gives folks who have an idea or a proposal or something going on here and they're looking to find more collaborators or get more input, a chance to sort of get the gist of their idea out there and then provide some coordinates so that more conversation can happen. So the idea here is not to do any kind of a thorough presentation or really have any dialogue here. This is really a broadcast session, right? You're going to hear about a bunch of different things. There are abstracts for all the talks that are posted in the agenda, and we're going to go through the order as they're written in the agenda. All the slides are posted on the materials site as well, so if you see something, you can always go back and refer to it there. And I've asked the presenters to include in the abstract and also in their presentation some indication of what forum they'd like to continue the conversation in. So some people it's catch me in the hallway, some people it's we're going to talk about this in a working group, in some cases there are mailing lists, and so kind of varies based on the idea. So the format is simple and crisp. You get 4 minutes and that's it. At the end of the 4 minutes, we're doing the Lars Eggert time management rules. So I want to thank my IETF chair successor, Lars Eggert, for how to do this, which is when you hear the timer go off, I would like everybody to start clapping. That's the end of the presentation, okay? That's it. So you get 4 minutes and then it's over. So try to say what you got to say in 4 minutes. If you don't get to, if there's something that you haven't finished, you can continue the conversation somewhere else. The idea here is to keep things moving and not try to get into a lot of detail. I know that's hard for some people, but we've had really good success so far. So those of you who have been here before know that that's the case. Let's see, I think that hits everything. We've got 15 talks. I think that's going to run probably about 90 minutes. And so let me introduce our first presenter is Brett Jordan. Brett, come on up and I'll get your slides up and then we'll start. Are you ready to go?
Yeah, we have slides.
Yep. Oh, and here's the.
So yep. What do I push?
You just push the right arrow and you go forward, push the left arrow and go back.
Okay. Hi, my name is Brett Jordan. Today we're going to be talking a little bit about course of actions and automated playbooks and what does that mean. We do have a mailing list that you can monitor or you can subscribe to contribute. We've done an introductory draft that you can read to get some more information about this. And then we're also having a BOF on Friday at 9:30. So when we think about automated playbooks and automated courses of action, the reason why this is important is threat actors and their intrusion sets, their collective toolkits that you use. They're advancing, the attack surface is growing, and our ability to respond is slowing down. So defense is slow, it's typically very manual and very siloed. And so when we think about the way a threat actor is going to permeate a network, they're going to come in, and in this example, we're going to hit a mobile set of devices, and then the threat actor will move laterally and compromise throughout the network. And what typically happens is all of these different groups need to be involved at various stages to do the mitigation, remediation, and then future prevention. And so there's a lot of work that goes on and a lot of people need to be involved. So what is CACAO? It's Collaborative Automated Courses of Action, or playbooks. It is a proposed standard to deal with the creation, distribution, and then the monitoring of the action so that you know if they were successful, and if not, what would be the backout rules or the conditional logic around them. So it's fundamentally around prevention, mitigation, and remediation of threats in the cyber domain. What it's not is it's not an arbitrary solution for sharing data. It's not about documenting incidents and indicators, and it's not to replace any existing standard that exists. I lost mine. So what our playbook, so if you're not familiar in the SOC or the security operational side of it, typically you have a set of documents that describe how you're going to respond to a threat. And these will be documented. They're typically in a binder on a shelf, or they might be in a knowledge base article. And so you have to work with a lot of different groups. If you have different business units or different enclaves, that information needs to be shared. And it does not allow organizations to respond quickly or efficiently. So what we'd like to do is design a data model and a methodology for allowing users to collaborate and to work on them and to share them. So one industry example, like in response to something like Fuzzy Panda, you could have various entities or various groups define solutions for certain products in a portfolio. They could all digitally sign them, and then they could turn around and disseminate them. So an end organization would have some level of trust. So instead of going out to some blog post and trying to figure out what you need to do for Windows 10 Service Pack 3, you could potentially link this into threat intelligence and push this out through an ISAO or ISAC. Our BOF is on Friday at 9:30. My name is Brett Jordan. If you have questions, I'm here. You can reach me on the email list or lots of other ways. So thanks.
9 to 10:30, an hour and a half off.
Yes. Thanks for the Brett.
I feel like you have to pronounce it. Cacao. It doesn't sound right the other way.
No, I just like chocolate. So.
Okay, our next speaker is Linda Dunbar. Come on up, Linda, while I get your slides on.
So
There you go. Just use that right here.
okay, my name is Linda Dunbar. So here I'm just going to talk a little bit about some of the activities for SD-WAN because it's being scattered in different places, different areas. I was told it's good to come here, get more people to be aware where they are and how to contribute. If anybody in the industry, probably many people, most of you have heard SD-WAN, right? Sounds very simple. It's policy-based forwarding based on the application and policies and reaching the cloud. So that's like a 30,000 foot view of SD-WAN. From the surface, doesn't seem to have much work in IETF. But if we peel the onion, if you look in detail, and actually there are lots of new things being introduced. So first we break the SD-WAN into two categories. One is basically over the internet, like you have a small branch office or you have a virtual router in the cloud data center to reach all the branch offices. So everything has to be encrypted. Another case could be service providers opening a new port for the internet offload for less important work. And also, like they have connections to the private network, which doesn't need encryption. So the key things here is really the WAN port management, because the SD-WAN node can be started in a cloud center, in a shopping mall, and so it requires zero-touch provisioning. For the control plan part, is basically I just want to give you an update of the current work. Once in the routing area, we have a problem statement and gap analysis in the RTG working group, and in the IDR, we have a draft to propose a new address family for the WAN port facing the ISPs. And for the BAS working group, there's a secure EVPN, secure L3 VPN, talk about how do we stretch the PE from the private links to the public internet. And in the security area, there are two activities there. One is the IPsec, SDN controlled IPsec management. Another one is how do we do the pairwise key management, rekey, and how do we utilize the SDN controller to do that. In the ops area, there's service model. How do we start SD-WAN services? So here are some of the current work. And if anybody interested, please come to those working groups, or you can talk to me in the hallway. Thank you.
Thank you, Linda. Okay, our next speaker is Anders Rundgren. Anders, come on up.
Hello. I'm going to speak about something that maybe interests a few here, web security systems. I've been working with web security protocols since ages back. You can see that, I guess. But I started with XML as everyone else, but did the switch to JSON. And it was relatively painless, but there were things that we didn't got from the XML world. One thing we didn't got was complexity, and that was good, but there were other things that we may need, like this one. Everybody sends messages with JSON over HTTP. Some want these messages to be signed, but there is no standard for doing that. So those who are interested, they essentially build their own stuff today. There's absolutely nothing wrong with that. These solutions work. The question is, couldn't there actually be a room for a standard for this? And that is what this is talk about. This is then my contribution to this, called Hotrfc, for signed HTTP requests. It is not enough to just sign the body of an HTTP message. If there is a body, you must also sign other things that make up the complete message, like the URI, the method, and if you have information in headers that are important, you should sign them as well. And of course, a timestamp is always good to have. This is a JSON-based system. That means that the body must be in JSON. One of the things that are rather specific with this is that the whole signed request becomes a serializable, a self-contained object. That means it can be embedded in other objects. Okay, my time is gone?
No.
Oh, okay, good. Okay, and for the cryptography, I have not invented anything new. I just reused the YOC stack. There is one new thing that will be discussed tomorrow at SecDisp as well, and that is the use of canonicalization. It has been said that it is impossible to canonicalize JSON. Given certain constraints, you can do that, and Hotrfc depends on that. Canonicalization is needed because there are different dialects, or let's say variations that are completely valid JSON-wise, but would create problems when you sign. So the endpoints, the one that signs and the one that verifies, they must have a normalized or canonicalized version of the message. On the wire, you can still send your old JSON as today. Here is a real-world example, although a little bit ridiculous, with a payload of 2 properties, and then there is a security element holding the important things of the transaction. Everything here is signed except the last element that contains a JSON web signature element, a detached. So it's not very complex compared to the XML standard, the VS stack or so. And my mission here is to see if is there any interest here in IETF to make this or something similar as standard. And it is not just a theory, you also have live code to look on, and you can even test this program immediately on an online service. If you hit the long URL, you are actually doing a secure request using this system. This one is without the body. Okay, time is gone.
Thank you, Anders. Okay. Thank you. Our next speaker is Michael Tooman. Michael, please come on up. You have a keynote, right?
Yeah.
There you go.
Okay.
You want to advance it yourself?
Okay. My name is Michael Tumem. I'm a scientist. I'm adding a new feature to HTTP that changes an old design assumption. So the web was designed for pages that don't change very often. And so HTTP is a request response protocol where the client asks the server for a page, the server gives it. But then what happens if the page changes? That connection's already gone. And so the user just has to click reload and issue another request. And this made a lot of sense when most pages were written by hand. They don't change very often. But then, just 5 years later, pages are changing like every week or two. And they start to get generated from a database. And now to hook up the database to HTTP, people, whoa. I pushed another button.
That's all right.
Can you help me out?
Yes.
Okay, so there we go. So now to connect to the database, you have a multi-view controller framework. And this is the first thing people had to learn outside of HTTP itself to start building dynamic sites. Then the site starts changing without even clicking reload. And for that, we have this JavaScript thing you have to figure out. And then you have to connect it to the server with an XML HTTP request. And now today, sites are changing all the time. We expect them to synchronize with everybody out there. And there's still a reload button, but you just don't click it because there's this mammoth pile of JavaScript behind the scenes. And you have to figure out how to write two MVC frameworks, connect everything together. There's more stuff. And now you have to deal with all the stuff, so we tie it together with more stuff. And this is why web programming really sucks today. And most of this is just junk outside of HTTP. So we're going to make HTTP handle change so that you don't need all this junk. And the way you handle change is you add synchronization. There's a bunch of new technologies out there. I hope someone's interested in them. And this is the result. So all that junk inside it, all those little gray boxes, turn into black boxes. Those are all stuff that's on the protocol now. It's automatically done for you. You don't need to learn all this crap. You don't need to write the code. You don't need to wire it all together. In my experience, it cuts down the code you write by about 70%, 70%. And since all this stuff is now on the protocol, that means that every little piece of state in here has a URL, and it's all on the open. So you're not just linking pages together. In HTTP, the pages have URLs, and you can link a page to another page. But now the state inside of your site can be synchronized with state inside another site. And so we can share our state together. This makes the whole web much more open. You can, and here's how it works. So this is why we call it a braid. So this is so every little patch, it's communicating in diffs or patches. Each patch has a little color here. The patches connect together in a braid. And when you have two computers that modify the same state, the braid forks. And then it merges back together down and flattens into a single dimension. And this is basically, this braid is representing space-time. And space-time forks, becomes relative, and then it collapses back down. And by collapsing space-time, you're able to program as if multiple pieces of state on multiple servers are in the same place. It makes it that easy to write your code. And it solves all these problems in the web. Caches don't get stale anymore. The network is much faster. Every text area becomes a collaborative editor, like Google Docs. Multiple people can edit it at the same time. You get an offline mode for free. And so this is my first time here. I'm interested in finding anyone interested in any of this stuff. And we're meeting on Tuesday evening at dinner. And information is on this website, braid.news. And if you see me, I'm the guy with the beard. There aren't any others. That's it.
All right.
Thank you.
Thank you, Michael. Actually, I'm the guy with the beard. Okay, our next speaker is Ronnie Evan. Come on up, Ronnie. Hi. You want to advance yourself? Just the right arrow.
Hi, I'm Ronnie Evan, and I'm happy to present it where there's no, you cannot go to the line and say anything against it because it's something that it would be probably cause a lot of discussion. The issue is fast congestion response in data center. So the problem is that we want to address is that there are high link speeds in the data centers are making network transfer complete faster in fewer RTTs. Short data burst requires low latency, while longer data transfer requires high throughput. The current congestion control is using ECN and is reactive. On the congestion, the switch marks the ECN bits, and the receiver notifies the sender. The sender reduces the transmit rate and increases it back based on predefined policy. And that's basically based on some not complete information, but just information, partial information. TCP, data center TCP, extends the ECM processing to estimate the fraction of bytes that encounter congestion and scales the TCP congestion window based on this estimate. Quicken RTP report back the number of ECN marked packet, and there's also work now for doing it also for TCP. Data center internal communication protocol is in most cases RoCE v2, which is InfiniBand over UDP. Now, currently the link layer flow control based on IEEE 802.1 is used to provide a lossless network in the data center, but has problems with head-of-line blocking. There's an example here. For example, X can be that's one to sense to Y may be blocked because F was blocked because of outgoing to 2G. So we are looking at new direction to have a proactive congestion control that will provide a faster convergence time. Currently, the switch only monitors congestion state. The data center analyzes, react based on partial information. The switch can provide better congestion information, allowing the sender to react faster. We know about the direction that was tried before in Plus, but what we are looking here is we're looking for something that will work only for intra-data center environment, where both endpoints and the switching fabrics are under a single administrative domain. Same requirement as also currently in DC TCP. We don't have any prepared, or we're not doing anything in this meeting, but if you want to talk with me or want to do something about it, please contact me. Thank you.
Thank you, Ronnie. So let's pause here for a second. I see folks are, no, you can come on up. Folks are standing 3 deep in the back, and there are lots of empty seats up in the front for you through a few rows. So if you want to have a seat, sit on the floor, something like that, tired of standing, we'll take a break now. You can come and have a seat. All right, they don't want to move. Fine, we'll keep going. Okay, so this is Florian Dold, and
Hi everyone, so this lightning talk presents the pay-to-URI scheme. So what is a pay-to-URI? Just how you can click on email addresses to typically open your email client. The goal of pay-to-addresses is to be able to click on this URI and instead of sending an email, opening a banking application to send a payment. So for example, here in this URL, you would send a donation of 25 euros to this European SEPA account, DE12345. So formally, these URLs represent a pre-filled pro forma invoice, and when you dereference them, there is a dispatcher that will invoke a handler specific to the payment target type that then will ask you to complete the payment. The syntax of this is pretty simple. It's pay_// then the payments target account type, which currently we have defined this for SEPA, for Bitcoin, for American ACH, and for the Indian UPI payment system. The path after this identifies the target account or wallet, and the options after this can be the amount, a human readable message, a computer readable instruction, a creditor name, or a debitor name. So why does this need to be a generic URI scheme? We want these to be clickable in all kinds of applications like browsers, email clients, text chat programs, screen readers. So the easiest way to achieve this is to really have one URI scheme instead of asking applications to implement this kind of interaction for various payment schemes. And also a very common situation is that I have multiple banking applications for the same scheme. For example, if I have account at various European banks, so I want some central dispatcher in my operating system to handle this situation correctly and to ask me which banking application to open. And also all these URIs share common concerns for syntax, naming, and so on. And so doing this with all kinds of URI schemes for different payment systems would be very cumbersome. So now you may ask, there's this web payment standard. What about this? This is completely orthogonal to Pay2. So web payments are a standard for things in the browser that have a JavaScript API, and it has different goals. So it's basically an API to get customers' payment information, to manage it, and to do payment flows inside the browser. So if this sounds interesting to you, please read the draft.pay2 and provide feedback. Also, if you have experience with payment systems, we would be interested to hear whether you can think of any more target types or maybe generic options. And you can implement this in your own application and discuss this with us via email, for example, on the URI review mailing list. And yeah, here's the link to the draft. And feel free to talk to me. Thank you.
Thank you. Okay, Marcus Amend is our next speaker. Come on up, Marcus.
Hi, my name is Marcus Amen, and as you could guess from the dominating color on the front page, I'm from Deutsche Telekom. And today I want to talk about multipath transmission for UDP or IP traffic, which is also subject of the 3 drafts mentioned on the front page, and yeah, just submitted before this on IETF. Yeah, what is our motivation? What is our driver? That is basically multi-connectivity network architectures. And exemplary, I have 2 network architectures. One is the hybrid access, which brings higher bandwidth and resilience against outages for residential customers, extending the home gateway by a second access link. And on the top, we have the ATSS specification. That is something which happens inside 3GPP release 16 for 5G, which combines cellular and Wi-Fi access for end devices, basically smartphones. Yeah, here on the second page, I have an excerpt, a traffic mix from a big European ISP, which states that the formerly dominating TCP has now a competitor. It's mainly QUIC over UDP, so that we can state that future multi-connectivity solutions, future multi-connectivity networks should not only comprise TCP, they have to be IP enabled, they should support IP. And findings so far is that there is no satisfying solution accepting the multipath TCP, but which is limited to TCP though. Multipath QUIC, which from my assumption is often a misunderstanding, is not able to work in such scenarios like ATSS or hybrid access. That's why we developed multipath TCP and an IP-compatible framework. The architecture you can see here in this picture. So we extended first, and that is subject of the first draft. You can see on the slide, we extend the DCCP by a multi-path capability. And in the second draft, then we defined a framework which defined the scheduling and reassembly or reordering scheme, and also defines an encapsulation scheme, which is here, which you can find in this picture as virtual network interfaces. And the third draft defines a rearrangement of the DCCP header to look like UDP to path today mailboxes. Yeah. So thank you for your attention, and for further discussion, yeah, you can catch me right now or during the week. You can send me an email. You can join the discussion on the Transport Area Working Group mailing list, or you can join the presentation on Monday's Transport Area Working Group session.
Thank you. Our next speaker is Spencer Dawkins.
So I'm Spencer Dawkins, and I wanted to talk to you all about performance implications of path characteristics, or what I'm calling PIPC. So how we got here is basically in the late 1990s and early 2000s, we were finding a lot of links that did not work very well for TCP. Aaron had the TCP over satellite working group, and working with a key problem with very long RTT interaction with slow loss recovery. I actually met Aaron bringing a proposal for TCP over cellular, and the ADs suggested a structured approach instead of TCP over foo links. So we did performance implications of link characteristics working group, and links that were slow, links that were asymmetric, links with errors, and we did advice for subnetwork designers and about automatic repeat request and about performance enhancing proxies. This was adopted by the WAP forum for version 2 of the WAP specifications. Life was good for a while, but things change, and this is a off the top of my head list of things that have changed since 2004 in networking. But of course, down at the bottom, satellites still have nice long RTTs. So I think the high order bit here is that our focus is turning from the assumption that any problematic part of a path would be a first hop link, which is what we were talking about a lot in the late 1990s and early 2000s, and saying that paths are more complicated, especially if we start to get multipath capability, and we can't really do PEPs, for better or worse, with transport encryption. So what I'd like to do, since the Code Lounge is for brainstorming, I'd like to brainstorm a bit. I want to have a side meeting in the Code Lounge after the last session on Thursday to talk about whether it's time for a discussion about paths and performance, and if so, what problems are in scope, what's research, what's engineering, which parts of the problem space fit in already chartered working groups and research groups. I know there are some. And what are the next steps between IETF 104 and IETF 105? I'm stepping down from enough positions this week to where I'm losing a dot a day until Wednesday. So please feel free to grab me anytime after Thursday morning or later. But like I said, the side meeting would be Thursday after the last session. Thank you all.
Thank you, Spencer. So our next presentation is on loops. Is it Yi Zhao or Karsten? Yi Zhao. Okay, come on. This is Yi Zhao Li. Yeah, give me 1 second.
Okay.
Start whenever you're ready.
This is Yi Zhao Li. I'm going to talk about this localized optimization on path segment, which we call the loops. Okay, The loops, actually, the basic function is try to provide the local best effort reliability. So here, local actually is not the local area network. Rather than end-to-end, it means between two overlay nodes. You can look at the picture to show the fundamental use case of that. To talk about some backgrounds and opportunities, in current practice, the PEPs, performance enhancing proxies, is becoming to an end with an increasing deployment of the encryption. And at the same time, network nodes, including the virtual nodes, which are created from the cloud workload, are becoming more and more powerful. So it's viable to trade the processing power against the path or segment quality. So Loops is trying to capture those opportunities to provide the optimization within the segments of the end-to-end path. So the main feature we are expecting from Loops is to do the local in-network recovery by either the retransmission or the FEC, forward error correction. So there are basically three elements of the Loops solution. The first one is to do the local recovery as indicated in the picture. In our particular usage scenario, is between two overlay nodes. And there are two building blocks in order to perform the local recovery. The first one is to do the local measurement, measure the segment delay and the delay variation. And this kind of measurements can help to decide whether a packet was lost due to a local congestion or some other, some other like random events. And the second building block for local recovery is the congestion interaction. That means how to interact with the upper layer end-to-end congestion. So we are thinking to use the ECM for congestion cost loss. We're expecting the loops will benefit most to the non-congestion loss in terms of the throughput for the longer flows and in terms of the flow completion time for the short flows. So we're scheduling a side meeting on Wednesday afternoon, 1:45 in this room, Barcelona. And the purpose is to discuss the technical problems and trying to discuss, are we ready for above in this area? And here are two related drafts. So you're welcome to join us, or you can catch me or Carsten in the hallway. Thanks.
Thank you, Yisha. Our next speaker is Paul Congdon. Yeah, just right here.
Right there, okay. Hi, I'm Paul Congdon. I'm here to talk about what we can do to make high-performance computing and RDMA networks scale on the order of cloud networks today. Famous quote from a very recent activity in the industry, the future data centers of all kind will be built like high-performance computers. As you might know, NVIDIA just made a big investment in Mellanox. So traditionally, high-performance networks were, kind of custom, small, InfiniBand type networks that had their own link layer, flow controls to be lossless. Those protocols weren't really tolerant of loss. More recently, we've done things to run those protocols over IP protocols. So we have iWarp, we have a whole suite of things here in the IETF, and then in the InfiniBand group, we have Rocky version 2, which runs over UDP. The reason why this is more important is that the results that we're getting out of these networks are no longer just solving weather problems or cracking DNA. They're actually doing everyday jobs for us. So this is really important to get large-scale high-performance computing into the mainstream. A famous slide from the SNIA organization that talks about all the different stacks and shows the evolution of RDMA. We started with InfiniBand, pure InfiniBand on the left-hand side. There was obviously, that's a separate network. When you want to run other applications, we needed a different NIC. Then they started to run InfiniBand protocols over Ethernet, but then it wasn't a routable protocol, so that became a problem. We had a very complex layer 2 congestion control that was end-to-end that was built as well that wasn't very widely deployed. So now we're in this Rocky
V2 phase where we've run that over UDP and we get IP routing and all that. So we have had some scale, but there's still some incomplete specifications on congestion, and we're still relying on layer 2 flow control, which has lots of problems. In the IETF, of course, we have iWarp, but to implement it, there's a lot of tricks you need to do to TCP, like DC TCP and others. There's some concerns about slow start. So what if there was a Rocky V3 or an iWarp++, something that we could improve upon? So that's what we're talking about. So by hyperscale, we mean, again, cloud scale, thousands and thousands of things, being able to, rapidly deploy things, automatic provisioning, having a mix of this traffic along with other types of traffic, but still maintaining the high throughput and low latency that you need. There's been a bunch of papers and work. I've cited several of them here that talk about, how we can scale RDMA using commodity Ethernet, running iWarp over connectionless protocols. That was talked about several years ago. How to tweak ECN for data centers, and then again, just sort of looking at what changes we might make to get RDMA to run over networks. So there is a bunch of work that's happened in the research community. There's a draft. Okay, there's a draft here that describes the problem statement and talks about some things that we could do. That's available here at the IETF. So what if, we could do this? What if we didn't have to be completely lossless? How could we get low loss? What if we ran iWarp over UDP like a quick-like thing instead of TCP? Would that solve some problems? So, can we do this hyperscale? So these are some thoughts. We're going to have a side meeting tomorrow morning, 10 a.m. Couldn't find the perfect time, but tomorrow at 10 a.m. In the Troyoka room. And would love to chat. I'd love to hear from operators or people that run high-performance computing networks as well to understand why they can't scale today and what we could do to talk about fixing that. Okay, thank you.
Thank you, Paul. Okay, our next speaker is Jeffrey Yaskin. It's the right here. There you go. Start whenever you're ready.
Okay, I'm Jeffrey Yaskin. I work on Chrome, and I'm talking about web packaging this week. In a bunch of, we're looking at a bunch of use cases for this new system. In emerging markets, lots of people aren't online the whole time, and so we want them to be able to share web applications the way they currently share Android apps, peer-to-peer, rather than re-downloading them over the internet. There's a lot of dislike for Google's AMP technology. I don't know if raise your hand if you don't like AMP. Great. So we're trying to fix that. We already have something working where it gives you the right URLs. We're working on a way to avoid the need for the AMP format itself in order to do the things that Google Search does with AMP. And that's enabled by web packaging. We want, when a whole bunch of people click a link to one target, we want to avoid knocking it off the internet. We want to enable neat things like binary transparency so that you know that you aren't being given a particular compromised version of an application specific to you. We want to optimize downloads of things like JS modules, which are often very small and can be compressed better if they're bundled up together. And so we've got these two proposals that add up to web packaging. One is signed exchanges, where we sign the request, content negotiation information, and the response headers and body. We use a TLS-like certificate that's not exactly TLS to avoid some security risks, or make all the security risks opt-in. We expire it quickly, and we have a way to update the signatures because of that short expiration. We also define bundles, which are a random access and streamable way of grouping HTTP exchanges. Chrome is shipping a version of signed exchanges in Chrome 73. This does not mean that it's fixed. We've designed in ways to upgrade that and drop old versions without breaking without breaking the user experience when we do drop those. So you can experiment with this today. but we want to get it in a fully consensus form, get everyone to agree on what we're doing, and then upgrade Chrome support to whatever everyone agrees on. So we're talking about this 3 times this week, and there's a bunch of ways to give us feedback outside of the meeting. We'll be talking to dispatch to see where exactly in the IETF this fits. We kind of expect a BOF at the next IETF meeting that dispatch will tell us for sure. We're having a side meeting on Wednesday to go over everything in detail and possibly work on a charter for that BOF. And then we'll be presenting signed exchanges to the HTTP working group on Thursday. HTTP working group will probably just be a quick overview. It's not a very long slot. Let's see, Kohei, could you wave? So talk to either of us if you want to talk in person this week. Otherwise, send us email or file issues on our GitHub repository. Thanks.
Thank you, Jeffrey. So next we have 2 talks by Ted Lemon, each of which will conform to the 4-minute limit, just in case there's any confusion on that. Second here. All right, start whenever you're ready. Oh, do you want to advance?
Oh, yeah, thanks. Yeah, so I'm here to tell you about some technology that is currently available in Windows, Mac, Android, iPhone that you may not know about, and also the developments that we've made on it recently. If you're familiar with DNS, this isn't going to look very strange to you. Normal DNS allows you to look things up by hostname. You can find services like mail. You can type in the name of your printer and it'll work. DNS Service Discovery adds the ability to enumerate services. So the first 3 things are pretty normal stuff that you would see with any sort of DNS, but the 4th is DNS Service Discovery, where we list the printers that you can find. There's a problem with working from notes. So DNSSD provides the ability to offer a service, the ability to enumerate services that provide servers that provide a service, and the ability to choose a particular server. DNSSD Service Discovery works quite well today. So we didn't invent anything new on that end. So if you want to advertise services, there are a couple of ways that you can currently do that. You can use multicast DNS. Multicast DNS is very automatic. You just plug your computer into the network, and if there's a server on the network, you multicast and you find it. And then with regular DNS, currently you would have to type in a bunch of information in the zone file, and then your client can automatically discover that information in the zone file using information that the network provides it. In fact, you can try that out right now if you are connected to the IETF network. If you go into Safari and tell it to print something, it will discover the local printer in the terminal room using DNSSD. We wanted to automate the DNS side of DNSSD. So multicast DNS is already automatic, but DNS is not. Populating the DNS is not. And so we took 2 approaches to that. One of them is to provide the ability to have an authoritative DNS server that is answering queries using multicast DNS on the back end. So essentially multicast DNS is the database and the cache is the database. And the other option is to have an authoritative DNS server that is updated automatically by servers. So the server just says, hi, I'm here with a DNS update. We have a couple of drafts that we've been working on in DNSSD. The discovery proxy describes the thing that I was talking about with the backend database. Then we also have an additional draft that describes a way to do something very similar to a DHCP relay, only for multicast DNS. So basically you have a really dumb thing on your router that a discovery proxy can talk to so that it can do MDNS on a link that it's not actually connected to. And then DNS update is kind of a nice way to solve the problem of I don't have good multicast service, or I don't want to be sitting on the wire talking all the time. So we have this extension of DNS update that basically provides a very carefully constructed, self-consistent set of updates that can be validated so as to so that it's safe to apply the update even though you don't really have an authentication, you don't have you haven't established trust with the client. And it provides the ability to do first come, first serve. So you can publish a key and further updates to that name will be validated using the key. We have a lease so that we can garbage collect stale registrations. And the name sticks around. So if your service goes offline, the name stays for a while and does get reclaimed by some other server. One of the nice features of multicast DNS is that it's timely. So if you look in your UI and you're looking for a printer, come see us tomorrow at Demo Happy Hour. That was a little too much for 4 minutes, sorry.
Do you have coordinates on where you want people to talk to you or
Yeah,
follow up on?
Hack Demo Happy Hour tomorrow, 8:30. Actually covered all the stuff I really wanted to cover, so. Okay, so some of you may have seen the dog food wiki, the dog food BOF proposal in the wiki for this IETF. It was a little half-baked. I didn't have time to really do it. So I'm going to talk about that a little bit. I don't want to stress you out, but I have a real concern about what we've been doing in the IETF for the last N years and seem to be continuing to do for the next N years. I think that we're walking blindfolded off of a cliff. I think that we need to seriously take stock of that, and I'm here to urge us all as a group to do so. So the IETF is a commons. It works because we make it work. If we stop making it work, it dies. If you look at what happened to something like British Rail, for example, there was a constituency, they wanted it, and then the constituency stopped arguing for it, and it slowly decayed and turned into this thing that got privatized and really isn't what it used to be back in the good old days. I'm concerned that something similar might happen with the IETF. If we go away, oh, I should be changing slides, huh? Let's see. British Rail, yeah. So if we go away, we're going to have trouble, right? This could wind up getting sold off to the highest bidder. And so who's we? The people in this room are aging. The average age of an IETF participant is growing over time. The group is getting smaller. And we're not attracting new young participants who would be interested in doing, the kind of people that we were when we were in our 20s or our 30s, right? They're not coming to the IETF in as large numbers as we did when we were that age. So why is this happening? I think one of the big reasons is because we meet 3 times a year. We're not using the tech we built. We're not meeting on the internet. I mean, we're building the internet. We're building this amazing high-speed thing that allows us to communicate worldwide, and yet we're flying to these locations 3 times a year. Now, I would have a lot of trouble justifying that to my 22-year-old niece, who is in the business of trying to save the world, right? This is a real problem. If we want idealistic young people to show up at the IETF, we need to not be doing this. So what to do? Thank you. I didn't. There isn't a train across the Atlantic. Sad to say, I would love it if there were, or a balloon. So IETF leadership can't solve this problem, right? They tried. We had the Many Couches mailing list. Pretty much everybody who showed up was in the IETF leadership. They did a nice job, but it was kind of all of these people in this room, we need to decide that we want to do this. We need to be pushing the IETF leadership. We need to be telling them that it's what we want. Otherwise, it's not going to happen. What I would really like us to do is get to the point where we actually have an IETF in the relatively near future that we are only going to do online. It's not, there isn't going to be a venue. It's just going to be online. IETF 112 maybe, I don't know, that might be too soon, but I think we could do that. So if this sounds like something that you think is a good idea too, if you don't think I'm crazy, please show up Tuesday night at the mezzanine bar and let's talk about it. Thanks.
What time?
Details. 8:30.
What time zone?
Central European Standard Time?
Okay, Wes, next speaker, Wes Hardiker.
This may sound a bit repetitious because Ted and I have similar issues and similar problems. I'm Wes Hardiker from USC-ISI, and I love IETF meetings. I've been coming here for a long time. They rock. I love shaking hands. I love giving hugs to my friends. But the reality is it's hard. It's hard for the world's climate, really hard for the world's climate. We're learning that quickly. It's hard for your body's health. There's been lots of proof on that. It's hard for various budgets. I have to justify my budget every single time I come. And it's hard for family life. I leave my family at home all the time. And is it time to really work toward a virtual meeting? I think it probably is. Where's the clicker? Thanks for stealing my
We
time.
don't have this problem in virtual meetings.
So current solution models have tried to emulate what we have today, right? You have this week-long meetings, you set hours around particular meetings, and the reality is you have to wake up at 4 o'clock in the meeting to have a meeting with the group that you like. That doesn't work. It's time to think way outside the box. So we need a new solution. We need entirely new directions. We need, new people, as Ted was talking about, and new groups. We need new requirements for what it actually means to meet, because the reality is when you don't meet in a physical place, the whole logistics around meeting are probably going to be different. You need a new frame of mind. And what this really boils down to is you need a revolution in how we do business, not just a simple evolution. And it's going to be commitment, right? This is not just Ted and I doing this. We've got to get everybody on board to actually make this happen, whether it's at IETF 112 or some other time. So I'm going to give you one example of ideas that I've been thinking of. Rather than the timetable you saw before, I'd like to hold every working group last for a week. Right, every working group lasts for a week. We still dedicate an entire block of time. We, there's a whole bunch of other parameters that go along with it. Maybe, how do we reproduce face-to-face meetings where all of that good stuff still happens? We don't lose that. How do we have an interaction form? Do we use video, audio, text? How do we increase the bandwidth, which is the thing that's always, talked about for IETF meetings? How do we keep that going? And, some ideas, we could, limit the number of posts per day so that, an entire long week isn't taken up by a couple of people. Maybe you're only limited by 2 minutes per comment period. Maybe there's a web page that allows you to, follow these streams. I don't have all the answers. This is yet one example to one problem. I don't know that a week is the right time frame anymore, right? How do we think outside the box? So how do we go forward with this? We need out-of-the-box thinkers. Again, revolution, not evolution. We need lots of people. That means everybody in this room. Every single one of you has got to help with this. We need willing working groups that are willing to be the guinea pigs. If you're a working group chair and you want to be a guinea pig for an interim, come see us. We need a place to hold these discussions about how to even do this. Mini couches was one thing that Ted mentioned. And again, this is actually has it Tuesday, 8:30 p.m. mezzanine bar. Let's meet there and let's talk about this, because this is not going to happen really quickly. Feel free to mail me, hardiker@isi.edu, if you want to make sure you get on a mailing list at some point. I wish I had a subscribe link so I didn't have to handle all these by hand, but I don't. So please, think about this, because this is not something you're going to solve overnight. And if I keep talking long enough, I'll get the really cool buzz, which is really what I'm waiting for at this point, because it's a cool car sound. But think about this, because this is not something you're going to come up with an answer tonight, right? This problem of meeting through an entire week took me a month to even think about it. It's like, that's what's broken, right? The physical world does not match the virtual world. How are we going to get there? This is but one problem, and I have but one answer that may work. We need lots of answers to all those problems. Thank you.
Thank you, Wes. So those of you who are looking at the agenda would think that this is the end, but it's not the end, that we actually have one more speaker and I neglected to upload it to the data tracker. So Alvaro, please come on up. Sorry about that. I'll get your abstract posted as soon as the meeting's over.
I left the clicker in my phone.
Oh, I got a new phone.
The clicker is not yours.
So I'm standing here for the next 4 minutes between you and dinner. I'm going to take the whole time. No, I'm not. So I'm here to invite you to a new type of session that we're going to have this week at the IETF. We didn't put it in the slides, but this is going to be Wednesday at 3 o'clock in the Grand Ballroom. That's where the hackathon happened over the weekend. So what we're doing is we have this new type of meeting that I just said that we're calling a deep dive, a technology deep dive. The topic for this time is going to be what we call modern routing architecture. The agenda is very simple. It's basically we got 3 people from 3 different router vendors to come to talk about router architecture, how our routers build, and especially what are the implications of that architecture in IETF protocols, or in protocols that we can develop. We have had in the ASG several sort of late surprises where we see things that are being done that can't really be happening on routers. Fragmentation, for example, or extension headers for IPv6, different things like that. We all have in our minds an idea of how a router works. I'm sure that all of you do, I know I do. But not all the routers that we think we know work the same way, or not all of them work the same way in reality, or for the different applications that we want to use them. So that's one of the reasons we want to have this. This is what we want to have with this is a deep dive into how the routers are built currently. So before this, we also had already a talk by John Scudder from Juniper at the IAPG, where he talked about some of these topics. This was very well received. The IAPG is a group of operators. So we think that it is time for everyone in the IETF to also be involved in this. We are going to be hosting this, as I said, on Wednesday at 3 p.m. in the Grand Ballroom. This is the first time we do one of these deep dives. Besides talking about this topic, we want to hopefully continue maybe trying to do other topics in some of the further IETFs. If you have any questions, you can find me, Spencer, Warren, or Karen, who are going to be the chairs and are sponsoring this activity. Thank you.
Great. So that's the end of our agenda. I would like to invite you all to come to the Pechacucha on Tuesday night. This is a non-IETF informal event, which will have, I think, 6, or depending on how cynical Brian Trammell is, by Tuesday, possibly 7 presentations of a generally satirical nature. And if you have ideas on how to make this event better, feel free to catch me in the hallway or send me some email. And if you have ideas and you'd like to get on the agenda for next time, you can just send me a note or send a note to hotrfc@ietf.org. So, sorry? The Pechacucha starts at 9:30. I don't have a room yet. There will be free beer, but it won't be unlimited. So, there you go. So thank you for coming. Go off and have dinner, and we'll see you all tomorrow.